Hello everyone, and welcome to this theory recording on power and energy. So power is defined as the rate of change of energy with respect to time, and it's an important quantity that is measured in watts. The equation for power, as defined as the rate of change of energy, which we know is W, or work, with respect to time, which is T, we should then be able to deduce that P is going to give us dW dt. But we can expand this further to say that, well, dW dt can be broken up into dW dq multiplied by dq dt, right? These two can cancel out, which still gives you dW dt, right? And if we further expand that, we remember that the rate of change of energy with respect to charge is known as the voltage, and the rate of change of charge with respect to time is known as the current. So we now know that a standard equation for power will be given as voltage multiplied by current. So there are different equations that we can use to determine power, and these are just extensions of the equation that we've derived in the previous slide and Ohm's law. So power is equals to voltage times current, and Ohm's law, which we know as the voltage is equals to the current multiplied by the resistance. So we can expand this to say that the power which is equals to voltage times current can also be given as, in place of voltage, we could say V is equals to IR, so that will be IR multiplied by I, so P is going to give us I squared R. And we could also say the current is equals to the voltage over the resistance, so we could say that the third equation would be the power is equals to the voltage multiplied by, in place of current we say voltage over resistance, so power is equals to V squared over R. Now what's important to note here is that this is applicable for different elements. So the equation 1 should be applicable for all elements as long as you have the voltage and the current. Equation 2 and 3 has to be applicable for resistive elements, mainly because you would not know the resistance of the other elements such as sources. So you wouldn't be able to apply equation 2 and 3 when dealing with sources because you're never given the resistance of a source. In terms of the conservation of power, we should know that power in a circuit is conserved. So if I have a circuit where I've got a voltage and I've got some resistive elements, the power that's produced by the source must be absorbed by the resistors. So the summation of the power, so PS plus PR1 plus PR2 must give you 0, and hence power will be conserved. Regarding energy, energy is the capacity to do work, and it is given in joules. And the equation for energy is given by E is equals to the integral from T0 to T of P with respect to time. This can also be expanded if you remember the equations from other subjects or modules where we say energy is equals to power multiplied by time. Also important to note the conversion between the different units of energy. So we know the unit joules, but you can also have energy in watt hours. Watt for power and hours for time. So 1 watt hour is given by 3,600 joules. When considering polarity and passive sign convention, it's then important to note that the previous discussion of polarity, which says that current will flow from the positive of the source around the circuit to the negative, will result in P1 and P2 that is absorbed by the resistors R1 and R2, and PS is the power that will be provided by the source. So it's very important to take note of polarity as well as how you would go about determining the actual values of power. So we know power is equals to VI, which is equals to I squared R, which is equals to V squared over R. And we should have an understanding that in a general sense, when passive sign convention is followed, the power of a resistive element should be greater than 0, and the power of a source should be less than 0. This is because the source provides power, and the resistance or the resistive element or the element will always absorb power. So the power here should be positive and the power associated with the element should be negative. But this is mainly when passive sign convention is followed. So when the current flows in a voltage drop direction. Thank you for watching this video and enjoy the course.